Hi, I'm Mr. Huber, and in this video we're going to talk about problem 1D. Well, f of x is minus 2x plus 1 squared. Find the vertex of each function, then rewrite it in general form, determine the y-intercept, and make a qualitative sketch of the graph. If applicable, work out the zeros. Now look, this is a bit special because it doesn't quite look like a function like this, ax minus u squared plus v, but only at first glance. Because when you think about it, you could write it as 2x plus 1 squared plus 0. Because this will be this is in fact a quadratic function, a sad quadratic function that has undergone a vertical stretch and has been translated to minus 1. The vertex has been translated to minus 1, 0. Now look, so you can read the vertex of this function directly. So the vertex will be at minus 1, 0. Well, you already know that the function is going to look somewhat like this. Because it's a sad parabola, it's been shifted to the left by 1 unit, and it does not have a vertical shift, a vertical translation, it's plus 0. So this will be it. Good, but let's carry on and rewrite it in general form. So f of x is minus 2x squared plus 2x plus 1. Now you distribute. F of x is minus 2x squared minus 4x minus 2. You can still see that the vertical stretch is still here. So the first number is still the first number of your original function here, or the first coefficient, so that doesn't change. You can always see, even when you look at a function in general form, that it will be sad and it will be a vertical stretch. But you can't see directly where the vertex is. That's only something you can do with the vertex form. Now look, f of 0, that means the y-intercept is, when you plug in 0, minus 2 times 0 squared, minus 4 times 0, minus 2, it's obviously 2. It's always the last number. So it's 0 minus 2. Don't forget, the general form is ax squared plus bx plus c. Well, in this case, a would be minus 2, b is minus 4, and c is minus 2. Okay, so this is just the general form. Now, this is the y-intercept, and we see there will be 1, 0 at 1. It touches the y-axis, okay? It doesn't intersect it in a proper way, it only touches it, but well, when you plug in minus 1, you will get 0, so that's a 0. Well, we will talk about that later, but now you can do a slightly better sketch, make a slightly better sketch. Well, at minus 1 and then minus 2, you see, this will be a point, and then over here at minus 2 will be another point because it's symmetric with respect to the vertical line through minus 1. And this is already a very good graph, although it's only a hand sketch, a qualitative sketch, not a quantitative sketch. But now you know the y-intercept as well. And it's clear, look, 1 to the left, and instead of 1 down, it's going to go 2 down because it's a vertical stretch. So it does make sense. And let's see what happens when you work out the zeros. Well, we already know the 0 is at minus 1 because it touches the x-axis there. And the y value at minus 1 will be 0. So that's a 0. But let's say we wanted to work this out. So f of x is equal to 0. So it would be minus 2x plus 1 squared is equal to 0. So first you divide by minus 2. That's not a problem. So x plus 1 squared is equal to 0. 0 divided by minus 2 is still 0. Well, please remember, you can divide 0 by any number. For example, I bring in 0 cakes and I distribute it amongst 10 people. Okay, 0 cakes divided by 10, no one gets a piece. But you can't divide by 0, but that's not something we have done here. Now look, you can either write it like this: x plus 1 squared is 0, and then x plus 1 times x plus 1 is equal to 0, or you can leave it at this. I'm going to talk about two possibilities here. Well, now either the first factor is 0 or the second factor is 0. Whenever you have a times b is 0, then the first factor is 0 or the second factor is 0, or both. So x plus 1 is equal to 0, so that means x is minus 1, or x plus 1 is equal to 0, so x is minus 1. So you have 2 times the same 0 at minus 1. Or you could do it like this: x plus 1, you take the square root, so you get plus minus the square root of 0. Well, that's still 0. And then x plus 1 is 0. X is equal to minus 1. So you can see we do have a 0 at minus 1. But we say that this 0 is of multiplicity 2. Because look, in actual fact, you could write it as a product, and then you have one 0 at minus 1, and in fact another 0 at minus 1. In German, you would often say doppelte Nullstelle. Well, here it's a 0 of multiplicity of multiplicity 2. Well, you can't see it here that well, but well, whenever you see x plus 1 squared or x minus 1 squared or whatever, you can see that it will be a 0 of multiplicity 2. So this is in fact a sad parabola which has undergone a vertical stretch, and it has one 0 at minus 1 of multiplicity 2. That means it only touches it. Okay, that's all I wanted to say. So I hope it wasn't too difficult. See you in the next one.